In this video, we look at evaluating trigonometric integrals involving products of sine and cosine functions, where sine and cosine are both raised to the first power, and the sine and cosine functions have different angles. Every other problem that we've looked at in this section, the sine and cosine functions have the same angle. There are a lot of brackets and parentheses here. I know it looks really bad, but it's going to simplify a lot when we actually have some values for m and n. So if you've got a product of two sine functions, and you've got an mx here and an nx here, it turns out that this product can be written using this identity. It's a difference of these two cosine functions. It's 1/2 of cosine of m minus n times x minus cosine of m plus n times x. If you have a sine times a cosine, you get a sum of two sines. The angles are m minus nx and then m plus nx. If you've got a product of two cosines, it looks like this. Now, I'm never going to ask my students to memorize these identities. Different teachers are going to handle that differently. But just keep in mind, if you're in my class, this is all on the sheet. You just have to know how to use it. So let's do a couple of examples. It's actually very simple. Let's say we're dealing with sine of 5x times cosine of 3x. All right, so I just look at which one of these I'm dealing with, identify m and n, and then go from there. I've got a sine times a cosine, so that's the second one. M is the coefficient of x in the sine function, so m equals 5. N is the coefficient of x in the cosine function, so n equals 3. So that means m minus n is 5 minus 3, that's 2. I also add those two guys together, I get 5 plus 3, and that's 8. So according to this identity, I get 1/2, and then I have a sum of two sine functions. It's sine of m minus n times x, so sine of 2x, plus sine of m plus n times x, so sine of m plus n was 8, sine of 8x. Super simple. And now you just have your kx modifications of your basic rules. So bring my 1/2 down. Antiderivative of sine is negative cosine. Replace your angle with a 2x. Remember, if you've got a constant times x inside, you're going to divide by that constant when you antidifferentiate. It's the same thing. Antiderivative of sine is negative cosine. Your angle this time is 8x. If you have a constant times x, you need to divide by that constant, and you're good to go. Now, if you want, you can distribute the negative or the 1/2 through, or you could factor out the negative. That'd be fine as well. Lots of different ways to simplify this. Negative 1/2 times positive 1/2 is negative 1/4, and the 1/2 times the negative 1/8 is negative 1/16. Super simple, easy breezy. All right. Now here's another one. Let's say you've got sine of 3x times sine of 10x. Now this matches this pattern up here. Now you can take it very literally. You can write this as mx and this as nx, but notice it's a sine times a sine. So it doesn't really matter which one you call m and which one you call n. I think I'm going to take my formula literally this time, although if you wanted to, you could call that nx and that mx. So according to my formula, taken absolutely literally, the first number multiplying x is our m, and the second one is our n. So m equals 3, and n equals 10. And then we add them and subtract them. So m minus n is 3 minus 10, which is negative 7, and m plus n is 3 plus 10, so that's 13. All right, so now we're here. We've got 1/2 of something. According to our identity, if you've got a product of sine functions, and we do, you have 1/2 of cosine of m minus n times x minus cosine of n plus m times x dx. N minus n, m minus n is -7, and m plus n is 13. Now, some students really don't like this. They would prefer that angle inside be a positive number. You can also just use the kx modifications quite literally here, and that'll work out just fine. I like to simplify it. I don't like to see cosine of a negative number or sine of a negative number. I like to use my identities about even and odd functions to simplify that. So that's what I'm going to do here. You don't have to, but it just makes it look a little bit nicer. You might recall cosine is an even function. And what that means is if I take cosine of x and I take cosine of -x, so I'm starting at the origin, I'm going x units to the right and x units to the left. I look at the y values. The y values are going to be exactly the same. That's true for every even function. So if I have a cosine of -7x, that's the same as cosine of 7x, because cosine is even. Now I'm just going to use my basic rules. So bring your 1/2 down and anti-differentiate cosine. Antiderivative of cosine is sine. Same is true there. Antiderivative of cosine is sine. Don't forget your plus c. Replace the angle with 7x and then divide by the 7. Replace the angle with 13x and divide by the 13. That's our answer. It's just not simplified. So let's distribute the 1/2. And we're good to go. That's what we get. All right. So let's do one more. We did a sine times a sine, we did a sine times a cosine, and I guess the last one to do is a cosine times a sine. Don't really even need another example, but why not? Just for practice. Let's say cosine of 3x and cosine of 4x. That's the only case that we have not looked at. Well, according to our identities, it's this last one. We're going to have a sum of two cosine functions. M is 3, n is 4. M minus n is -1, and m plus n is 7. So the integral of this is equal to the integral of this by our product to sum formula. We get 1/2 of a sum of two cosines. I have cosine of m minus n times x plus cosine of m plus n times x. M minus n turned out to be -1, m plus n turned out to be +7. And again, cosine is even, so cosine of -x and cosine of x are the same thing. All right, so now we can take our antiderivative. Antiderivative of cosine is sine. Antiderivative of cosine of 7x is sine of 7x. There's a kx inside, so we divide by the k. That's our answer. It's just not simplified. We get that. Now we talked about the identity for cosine. There's another identity for sine. Cosine is an even function. So this just might help you as you do some of your exercises. Cosine is even, so cosine of x and cosine of negative x are the same. I'm just going to draw a little picture for you real quick. I'm not going to spend a lot of time on this. But the idea is, with a cosine function, if you go x units in that direction and x units in that direction, you find the y values, they're going to be exactly the same y value. So cosine of pi over 4 is square root of 2 over 2. Cosine of negative pi over 4 is also square root of 2 over 2. Because cosine's even, you get the same thing on both sides if you go in the same number of units in each direction. Now, sine is odd. Sine looks like this. Oops, didn't do a very good job making it look odd. It is odd looking, but it's not, it doesn't look like an odd function. But the idea here is very similar. I go x units in this direction and x units in that direction. I find the y values. It turns out the y values aren't the same, but they have the same magnitude. Their absolute values are the same, they just have opposite SIGN signs. So if I went over here to pi over 4, I would get square root of 2 over 2. If I go to negative pi over 4, sine of negative pi over 4 is negative square root of 2 over 2. So these are the y values on my graph. They're opposites of each other. So this number is the opposite of that one. So I just take that one and multiply by -1 to make it an opposite. So as you're doing these, if you end up with a sine of a -8x or something like that, just know that you can pull that negative out front and call it sine of 8x, and it's going to be exactly the same thing. Now if you don't simplify it, that's totally fine with me. I'm not sure how the software will grade your online homework, but yeah, if I'm going in and grading it, you're going to get some partial credit, if not all the credit back, if you happen to do it with the negative angle. But this is what they're doing in the book, and this is what is getting them the answers that you see in the back of the book if you're checking your homework.